Good morning, everyone. Today we are going to continue our conversation about range of motion. And today we are going to introduce a very last kind of range of motion, which is called rotation. So before we start the topic, let's quickly just review the key terms we mentioned about rigid motion. As we mentioned, rigid motion is kind of the transformation. They move the location of the pre-image, but the after no matter what kind of transformation of rigid motion, the pre-image will keep the same. That means the size and the shape will be the same. That's why we always say in rigid motion will produce the congruent pictures. And also, as we mentioned before, um, the picture, the figure before move is called pre-image, and after the movement is called image. And we also we prefer using a little comma here to label the image, which is called prime. A prime, B prime, C prime. Okay, and also as we mentioned before, rigid motion has three kinds. First, translation, reflection, we already talked about this too. So today the focus will be rotation. So let's check several examples about rotation. Rotation simply just meaning turning around a center. As you can see, the left side is like a clock. And little center here, and also like this picture, we we turn this triangle 90 degree, and the direction we called counterclockwise. So this, and also one thing I want to remind you, this little center here, and also you can see this triangle is turning around origin. So this center is called center of rotation. Also, so before we start, like very detailed regarding how do we rotate a given picture, we are going to quickly review some key terms of rotation. There's three things we are going to discuss is center of rotation, and what's the direction of rotation, and how many degree of rotation we are going to discuss, okay? So that will be the focus for the first part. So let's check some key terms here. So as you can see, the center of rotation, as we mentioned, is basically is how do you picture rotate around which point. So as you can see, this clock here, this center is called center of rotation. But for direction, we have two kinds of direction. As you can see on this, picture here, how the clock moves around the center. This direction is called clockwise, and the reversed direction is called counterclockwise. So let's write down these key terms here. So as we know here, this is what we mentioned about the center of rotation. This is how we rotate around a certain point. And clockwise is how do you clock, just like how your clock moves. This direction is called counterclockwise. And then if we go the other way, if we reverse this one, this is called counterclockwise. So we have these two directions here, either clockwise or counterclockwise. And for angles of rotation, is actually when we rotate a given picture, it can be all different kind of angles. However, if we need to perform this kind of rotation on the coordinates plane, we are going to focus on certain types of angles, 90 degree, 180 degree. I can just go through this I can introduce through this one. So 90 degree, for example, I have a point, let's say 60 here. If I rotate 90 degree here, as you can see, this a quarter of the whole circle here is 90 degree, so I can rotate around this position. And then if I continue from this position, the half of circle here, then this is going to be 180 degree. If I just continue doing this from the start point, I just go 3/4 of this, and then I have 270. Then if I just go through the whole circle here, go back to original position, this is actually 360. So this is basically the different angles we're going to talk about. And today we are going to work on several different examples to see how do we rotate certain points. So let's check several examples here. The first example is we are going to rotate the point 90 degree counterclockwise about origin. See, as you can see, this is actually a description of the rotation. We need to cover several things. First, this is the original picture, which is, in this case, is a point. We need to rotate. How many degree we need to rotate? 90 degree. What's the direction? Counterclockwise. And also, what is the center of rotation? Is origin, which is this point, 0, 0. So in order to do this, the first thing we need to plot this point on the graph. This is 3, 0. And also this says counterclockwise. Counterclockwise, so we know counterclockwise is going in this way, right? And also we said going 90 degree. So 90 degree is going to be this 3. You can imagine this little bar I'm going to draw here. Rotate in 90 degree is going to be, this is 90 degree, so this little bar is coming here. So that's why the new location of the point is this point. So from 3, 0, this is 3, 0, become to 0, 3. Let's write down. So 3, 0 becomes 0, 3. It seems like we change the XY rotation. The X, this is before, this is XY, and becomes YX. And also, you know what? We have to put a question mark here because this is like very special point here. The next example, we are going to see more random point to see if we can still have same rule here. So this time we are going to rotate for 2. Same thing, 90 degree. But this time we're going to go clockwise. So as you can see for this example, how about we just choose a random point here? This time let's see, so let's say we want to rotate for -2. This is for -2. I'm going to rotate 90 degree here counterclockwise. Let's see how do we do that. So as you can see, the way you can do this is either you can imagine this is a round. I'm going to draw the little a round origin for 90 degree. Another thing, you can just rotate x-axis and also y-axis here. So for 4, we are going to rotate 4 here. And also for -2, we are going to rotate 2 here. So it's more like this little 2 piece here. So you can imagine this triangle. We rotate as this triangle. You see? So 4 becomes 4, and this little 2 here, this little vertical 2 becomes horizontal 2. So this is going to be our coordinates, becomes, as you can see, this is 2, 4. So the new rule, this one is 4, -2 becomes 2, 4. So that's why this rule we are going to erase. This rule, we use a new point to prove. The rule is actually when we rotate 90 degree counterclockwise is original point. First of all, the 2 position changes. XY becomes YX. And also the point is the Y from the negative to positive, meaning the Y will change the sign. You see the Y original point is like a very special one because 0, no matter it's positive or negative, it's not changing sign. So that's why we could not see the difference. But if we use a different example here, we see, wow, it's actually different. So that's how we rotate 90 degree counterclockwise. So let's work on the different example, and probably that will give you a more clear picture. Let's say this one. So this one, we're still going to rotate 4, 2. So let's plot this point. This is a 4, 2. And we are going to rotate 90-degree clockwise. So first, before you do that, think about where is clockwise, which is in this direction, right? So this is clockwise. So again, for the students, if you're not so sure, my way is sometimes I just draw the little triangle here. And I know this little corner is 4, 2. So 90 degree, I know this triangle, this horizontal line 4 is going to become this 4. And also this vertical one here, 2, is going to change it to this 2. So this triangle is going to become this kind of triangle. So this is 90 degree. And then from this little corner here, change to this corner. So let's read the coordinates again. So this is going to be 2, negative 4. You see that? So this is how do we rotate the point 90 degree clockwise. For 2, change it to this one. So for the students, if you're still not so clear, you can definitely draw on your picture and redo this point again to make it more easier for you to do this. Okay, let's see one more example. This time we are going to rotate. We are still working on the point for 2, but we are going to rotate 180 degree about the origin. So some students probably already noticed why we didn't mention anything about counterclockwise or clockwise. So if you think about this, 180 degree is like a straight line, right? This is like 180 degree. So no matter is counterclockwise or is clockwise, we will go back to the same position. So that's why when we rotate 180 degree, there's no need to mention clockwise or counterclockwise because it's no difference. So let's see. So for 2, since we're going to change 180 degrees, so we actually, this is around about origin. So let's draw the little line here. Since, we are going to have like 180 degree, it's going to be exactly a straight line here, right? So that's why it's going to be exactly on the same position, but go to this one. So it's going to be here. So this time is negative 4, negative 2. As you can see, when we rotate 180 degree, original 4, 2 becomes negative 4, negative 2. Everything just change to negative. It becomes negative 1. So if you think, remember the rule is more easy for you, can do that, but definitely use a graph to reinforce your understanding. So I think visualize this process is more helpful and very straightforward to this. Okay, so very last example, we are going to use a picture, use a triangle to reinforce our understanding regarding this rotation. So what we are going to do is we are going to rotate this triangle 90 degree counterclockwise about origin. First, this is our center of rotation. And also, as we can see, we have SLB for 3 different locations. We are going to rotate 90 degree counterclockwise. So counterclockwise, we know is going to be around here, right? So I'm going to repeat the process as I mentioned and repeat for all the 3 points here. So let's check. S is 1, 2, 2, 2. So it's 2, 2 here. So as we mentioned, you can draw a little triangle here to remember this is the position for this. So I just rotate another 90 degree, which is 2, 2 here. So this is going to be our S prime. If you think this process is a little bit messy to, it's not easy to do the second one, so you can definitely erase this process. And then let's do the second point. So second point is B is 1, 2, 3, 4, 1, 2, 3, 4, 5. So it's 4, 5. So this triangle will look like this one, right? So it's 4, 5. So all we need to do, this 4 becomes this vertical 4. So 1, 2, 3, 4. And then this 5, this vertical 5 is going to be this 5. So from this one, 1, 2, 3, 4, 5. So this is our B prime. As you can see, so basically before is horizontal 4, 5. All I need to do is 4, 5. So it's reversely. Now let's work on the last one. Last one is actually easy because it's on the x-axis. We know it's going to go back here. So this is 1, 2, 3, 4, 5. Then this 5 becomes vertically 1, 2, 3, 4, 5. It's here. So this is L prime. Now I'm going to connect all the points here to get the straight line. So B to L, L to S, S to B. Then as you can see, this is our new image. This is an image of rotation. And we also label everything like this way. Okay, so that's all the example. I know this video can be a little bit long, and we include a lot of example here. I hope these videos are helpful to make sure you understand this. Thank you so much for watching this. See you soon, everyone.